Yes, I'm a fan of Plan B, but I think we need to prioritize Plan A as well. And we're now going to hear about Plan A, restoring, improving Earth. The next speaker is Pablo Vidarte, who was featured on a list in Forbes called 30 to Watch Under 30, which is remarkable. Even more remarkable is that he was only 20 years old when he was already identified for his future potential. He is the inventor and developer of a system to generate electricity from the photosynthesis taking place in plants. Very interesting. And as such, he is the founder and CEO of Bio and the CEO of Arkine Technologies. Welcome, Pablo.
Hello. So, when will the biotech city arrive? The first biotechnological city in the world. First off, let me take the, okay, here it is. The first biotech city. What if I tell you that it was possible to generate energy from nature itself using biological batteries that are literally plugged in the soil? What if I tell you that this is done without even harming nature itself and without altering it? So what if I tell you that these benches are able to generate energy from the natural environments they have on top, with a hybrid system actually, and to power your phone even? What if I tell you that these panels are able to generate energy from parks and gardens and light up light points and automatic irrigation systems with nature itself? What if I tell you that these alien-like sensors or droplets are basically using the agricultural fields, our lands, to basically nourish and measure them, measuring humidity, temperature, pH, and sending the signal kilometers away just by using the soil farmers are already taking care of? Well, I'm not even here to speak about the rise of the biotechnological city, but actually the rise of the biotechnological world. This is something that began 7 years ago with a company that is called Bio, and that I founded. Basically, I've been doing a lot of things throughout my life, from software, AI, hardware, even mechanical engineering with external combustion engines, until through the most stereotypical story, which was basically having a dream and waking up at 3 a.m., I thought, would it be possible to actually use nature as a solar panel? And I created a team. They were volunteers in the first place. They were nanotechs, they were engineers, and we began creating prototype after prototype. And after a whole year, we actually funded the company itself. We basically succeeded achieving partners that were biotech companies, pretty much the leaders in the world, and overall, little by little, even with the support of the European Union and a lot of more entities around the world, even creating consortiums that were huge, actually, we started creating technologies that were pretty much unique. Not only the one that you've seen so far, but even technologies that were able to literally make us connect and communicate with nature itself, with life itself. I'm going to tell you a little bit about it just in a sec. But bear in mind that the path wasn't that easy. I mean, as you may suppose, when making a company, everything is not that easy. I actually began with two colleagues that were co-founders. They basically abandoned this whole adventure basically in the beginning because they thought it was too difficult to actually be achieved. And it was kind of, but right now I'm pretty happy to announce to you that it's something real. And first off, the question here is, how does it work? Well, I'm going to show you a very brief example of how this mechanism actually works, because one of the things that we are using is a very basic concept that is real since the 70s. Even NASA and the MIT were working on biological batteries. The thing is that they were applied to wastewater treatment plants. Not living plants, but actually artificial plants. They had like a ton of water coming in a current with a lot of organic matter inside, and they were able to break it down with microorganisms. Once they were broken down, they basically were able to extract the free electrons, creating a current of energy that was basically able to power whatever, sort of say. Our approach was absolutely different. What if instead of having something like this in an internal environment, we could have it in an external environment? What if we could use nature itself, which already has microorganisms, which already has organic matter, and by the way, they are recycled? What if we could use an environment like that and generate energy in a basically constant basis, like during day and night time, 24/7? Well, this is more or less what we're doing here. I mean, we're dragging organic matter thanks to irrigation. We're putting it inside our batteries, and once it's inside, we simply break it down with natural microorganisms, generating energy in the process. But apart from that, as I said before, we were also developing other technologies. And the other ones were basically using plants, sort of biological switches. In the beginning, we began with very basic concepts, like, for example, domotics. Imagine going inside a hotel room, touching a green wall, and being able to turn on the lights of that room. Well, that's pretty cool, but the thing doesn't actually stop here. So when we're talking about these technologies, it's actually very interesting because in this case, we are only perceiving human touch. If you touch these plants with a metallic bar or a controller or whatever, they won't get activated. They just get activated by the human touch. Plants are actually able to perceive the natural frequencies of human touches as well as any other kind of change. What we want to do is that instead of using, for example, sensors in agriculture that are able to measure humidity, temperature, etc., what if we could literally ask the plants, what do they actually need? Well, that's more or less what we do. And that's the other technology, detecting the natural frequencies of plants, which, by the way, they are electric. They are not mechanical like ours, but that's one of the ways in which they communicate. And it's one of the ways in which we are creating a huge, huge project. But starting with what the company is about. So far, we've created a lot of products. The only limitation has been the pandemic so far. But these are the ones that are already on the market. And the last two are the ones that have already been developed and right now are being tested with a lot of clients worldwide. From Singapore to Montana, we are already placing this technology around the world to transform cities and the countryside as well. So this has not only been done with our own facilities in Barcelona, but also we have a core in Ibiza, which is kind of the best place to actually have it, which is called the Biotech Botanical Garden of Ibiza. It's the first biotech botanical garden in the world. And what we're doing there is to replicate different environments, like a Mediterranean environment, a dunar environment, a saline environment, forests, deserts, basically everything, so that we can actually test our technology in totally unique ways. These ones can actually be visited, by the way, so you're absolutely welcome if you want to go. And the thing is that we normally tend to enjoy a little bit the testing these technologies. So first off, we even made a biological piano using the last technology I spoke about. This is actually very cool because it can be even transformed to mixing board with plants. Even David Guetta was playing it, so it was totally recommended if you want to have fun. But the thing is that this can be implemented to many other industries, like, for example, transforming our shops, our cities, our streets. We even worked for the City Hall of San Jose in Silicon Valley to create the 21st Century Monument, which basically combines every single technology that we've developed and a little bit more. These panels, for example, they are the ones that I was speaking about before. They're intended to basically be placed, as I said, on parks, gardens, and power any kind of thing, but starting with light points and automatic irrigation systems. For example, right now we are starting with the benches, which basically are having one of these panels in each of these hexagons so that we can literally transform every single part of our cities. I mean, literally imagine the applications that these technologies have in urban environments. This is just one mere example, but there are a lot of other things to do. Talking about that, in agriculture right now there is a huge issue, apart from the ones that are traditional, so to say, but bear in mind that right now agriculture is modernizing a lot. They are using sensors, humidity, temperature, pH, to apply the most efficient irrigation and additional fertilizers. And the problem with these is that they're really useful. I mean, they measure basically everything and they save a lot of time to farmers. But the problem is, how do you power these sensors? Well, right now, they are powered with chemical batteries, regular chemical batteries that need to be replaced every single year. This means billions, and not even that, actually trillions of batteries around the world that need to be replaced. And when talking about these, actually they've even used solar panels to try to solve the problem, but they've seen many other problems, and that's one of the issues of why they're actually using chemical batteries in the 90% of cases. And is that solar panels, they need to be placed at a certain height, like 60 centimeters. They need to be protected from dust, from hail, from rainfalls, from wind, even from getting stolen, and after all, they are even more expensive. What we do, it's literally a biological battery to solve this problem. So, as I said, these alien-like droplets or seeds, they are placed along fields, in agricultural fields, nourishing from the soil inside. The lower part is basically the battery. The battery, as I said, it's absorbing the organic matter from the environment and creating energy in the process. And on top, what we do is to place basically the sensors, whatever sensor you need, and the communication system, which, as I said, sends the signal kilometers away. This is a great way to actually map terrains in agriculture. And it's kind of the first thing that we're starting to do when talking about that huge field, the agricultural field, to create a huge impact. But we are also even powering valves and irrigation systems, as you may suppose. The thing is that this is just the beginning for what is about to start right now, which is a biotech revolution, not only of our bodies, but also of our own world, of where we live. We want to live in cool places if we want to live forever, actually. And the thing is that a very common question that I've seen so far is, and what's next? So what we want to do, in our case, it's not only to cover fields around the world with these technologies, but actually be able to absorb the CO2 of the atmosphere. So we were normally thinking about technologies that were able to avoid the environment from getting worse, like solar panels and stuff. But what if there was a technology that was literally able to absorb the CO2 from the atmosphere and this at the same time? Well, we have a very ambitious goal by 2050 to reduce up to 1% of the total CO2 emissions predicted by then. And even with this, the question still is, what's next? Well, we actually have a very, very ambitious goal, which is to create the first evolutionary and living monument on Earth, which is a living library. And in this case, the living library, it's literally about storing memory within nature. What we want to do is a library that is totally open to the environment, where you can walk through, where you can touch the plants and connect with them. And as I said, within that nature, we store memory. When you touch that nature, you're even able to hear voice messages of people that want to leave a footprint for present and future generations. It is going to be a global living network. It is going to be something that we're going to see in many cities with a lot of very different shapes, like this one, for example. We want to make it evolutionary because, well, you know, memory, especially human memory, is actually very evolutionary. And when talking about even constructing, building new monuments, we are even able to create things better and better every single year. So what we want to do is to create a global memory with nature itself, a totally different monument than what we are used to. But when thinking about what the future will look like, if we think bigger and we actually still keep on asking the same questions of what's next, and what's next, what we will realize is that humanity is basically destined to greater and greater purposes. I actually wrote a book which is basically called A New Earth. It's basically this one that you see here, and it's about the inevitable future of humanity itself. What are we going to find right after what we already know? A lot of transhumanists are thinking about extending their lives and being able to create a totally different world. And that totally different world, it's pretty limited from my point of view. I think that we can reach not even the stars, but what is actually beyond. And in this work, A New Earth, I totally speak about the absolutely different futures that we're going to see. And after all, I realized that there is one specific conclusion. If we don't kill ourselves, we're going to end up being the creators of universes. We're going to be the creators of new realities. And that's what I speak about here. And by the way, for this third day, I'm going to give the books here for free. So if you go out, just ask for them. You're going to have them. You can bring them home if you wish. And overall, thank you very much. If you have questions, feel free to ask. This has been our adventure. Thank you.
Thank you so much, not just for a fascinating talk, but for bringing us back on time. But we will take a few questions. What's next? I've heard it said that trees communicate with each other, that they have roots that go underground and somehow send signals to neighboring trees, and there's fungi involved and bacteria. People say it's not the World Wide Web, it's the Wood Wide Web. If we are trying to enhance the environment, should we be paying attention to the connectivity that's already there? Is that part of your vision for the future?
Yeah, and by the way, that is kind of what we already knew, but actually it was a few months ago that it was discovered that plants not even communicate only through their own roots and earth itself, but also through sound. One of the many different entities with whom we're collaborating is the Tel Aviv University. And they were actually the discoverers of this factor, which is basically that if you're an animal eating a leaf and you go kilometers away from there and eat another leaf from this very same species, that leaf is probably going to be toxic just because they communicated through infrasounds. We're not really able to hear them unless you use specific machinery, but every single year we're discovering a new way of connection that actually nature has and hasn't really revealed yet to us. And it's actually a very magnificent concept, very similar to the films of Avatar as well, but it's real. After all, they have a very cool social life, and we don't even know about it.
And maybe we should know more about it before we remake our environment too substantially. Questions from the floor? There's one from up there. I don't know if somebody's got a microphone we can. Our astronaut is going to launch himself into orbit. There, thank you.
Hello, my name is Victor.
Hello.
Thank you for the talk. I was wondering, for the foreseeable future, what do you think is the main challenge or bottleneck for this technology to be implemented?
For this technology to be implemented, basically the main challenge is to not only scale it, which is something that we're already doing. I mean, it was kind of a challenge in the beginning, but actually gain consciousness all around humanity, because as you may suppose, when talking about incorporating new technologies, it is a pathway that is not that short in the great majority of times. And in our case, right now, it's basically gaining resources on time, because we're pretty sure that in the next 10 years, this is something that you're going to see on your own garden, if you have one.
Next question from Ahok.
There?
Oh, over here, thanks.
Okay, feel free.
Wonderful presentation, by the way.
Thank you.
And I'm in complete favor of using this technology for electricity generation. Since you mentioned plants for generating electricity, have you also considered aquatic medium? Because lots of corporations, even government, have requirement of generating electricity from the proteins, which sits at the bottom of the sea level.
Yeah.
Okay.
Yeah, we've actually thought about it, and even though it's not really our focus, it is a great field to actually explore. It's going to be as a homework for the following years, actually.
Right, right. And as the second part of the question, since you are also using plants as biological switch, is it based on biomimetics or different technology?
Actually, it's really interesting because it's used on the natural beatings of plants. As I said, we have a mechanical beating, plants have an electrical one. And they are conductive bodies at the same time. Even soil is a conductive body. So what we do is to literally just detect those changes in frequencies without even touching the plants. So if you have these devices in the middle of a field, you would not just read one plant, but kind of the general feeling of all the plants around. So it's a great way to know, for example, if there is an infection in a field or in a forest, if there is fire, if there is, a lack of water or whatever, basically.
Final question from the audience.
There was a question there.
The Martian goes.
Thank you very much. Well, because part of it was about raising energy, some sort of renewable source, I was wondering how this technology could potentially compare to other renewable energy options out there.
Well, it is kind of comparable. However, it is different after all. We all know what biomass is about in terms of energy, and it's pretty much used so far. Biomass is basically using any kind of organic content and creating energy out of it. The only thing is that right now biomass is just used to burn it and then generate energy from that burning. So even you could consider petrol as biomass. But the thing is that this is totally different because it's using life itself to generate energy. It's a very cool concept because after all, you could create a biological battery in a test tube. And if you do that, you will have basically a substrate, microorganisms, which is a living being, and an organic matter inside. And what you'll have, it's basically a lot of living beings inside living their own lives without even being conscious that it is all to provide energy for you. So this whole concept of kind of creating a microverse in a test tube to generate energy for you, it's kind of unexplored if we were speaking about applying it to nature itself. But as I said, this technology has been existing since the 70s. We just perfected it and translated it to the natural world.
And final question.
Okay.
Quickly.
Thank you. Thank you very much, Pablo, for this nice presentation. I like to see young people like you doing so many efforts to save the planet. The question, as I like thinking in volt, ampere, and watt, is there like a number, an idea of like, let's say, creating from this panel with photosynthesis, like a number what you can get like per unit, how many watts of energy that is be generated? Okay, right now we are working to actually, just for you to have an overall idea, to power a light bulb in a park with 4 square meters. Our goal in the short term is to be able to even produce up to 1 watt per square meter. And the thing is that this technology, it's even able, under very controlled conditions, to power like 40 times that. The thing is that we need to reach that point. This technology is starting right now, and it's like solar energy was 50 years ago. The cool thing is that we are increasing the power output of our batteries like way faster. I mean, since we began with the first prototypes, we were able to increase the power output by 1,000 times. In the last 4 months, we've been able to increase it by 6 times. So this incredible
increasing factor, exponential factor, we've been speaking about it a lot throughout all the presentations. It's something that will lead to a great change pretty soon. And that's why I was speaking about the possibility of actually reaching a global use of this technology in about 10 years' time.
So, 10 years' time, very exciting. Let's now give a warm round of applause, and thank you so much, Pablo.
Thank you.